You do see the screen, right? The shared screen, please confirm. May you please confirm if you can see my screen?
Yes, we can.
Okay. Okay, thank you. Today we're going to do or focus on geology, and geology is a chapter that I said I attached on Moodle. It's a chapter that we need to cover, but it's not on the textbook. So the PDF document of whatever it is that we will be discussing today is already on Moodle, and I asked you last week to please go through it. So I'm under the impression that at least you have an idea of what is it that we will be covering today, and then if you have any questions, please feel free to ask, right? Everything else regarding practicals or anything, I will answer those questions when we finish with this. With this, so the geology part of it, why is it important? Because that's where you always need to start, right? The subject itself is the civil engineering materials. So basically what we will be doing throughout the semester is we will be learning about different materials that we normally use on anything civil engineering related, right? So I will just explain. I just throughout the session, please understand that there's a way I will explain, and then towards the end, there's certain things that I will ask you so that you kind of understand.
85% yey'nkolo la abantwana bangakhokhi if school.
Okay, just make sure that you are muted on your side, right? Because it's yeah. So the objective is to understand the following, particularly when we're talking about the introduction to geology, right? So we're going to talk about the structure of the earth, the physical characteristics of minerals, and then the general formation and interrelationship of the major rock types. Before you get bored, let me just explain, right? So because we will be dealing with different types of materials, right, that we use in civil engineering, everything or every structure that we have it built on earth, right? So it's very important for us to understand the formation of the earth itself, and then in terms of different layers, all of that, and particularly on maybe the layers that we build on, so that we understand the characteristics of the rocks or major rock types that are found there, so that we understand in terms of strength, or how will the earth itself react to anything that we build on it, right? So when we are talking about the geology part, is where we will be dealing with the rock formation. How does it start, and what is it that you need to understand, and why, and how is that important, right, moving forward? So that's number one. The first thing that we need to know is that we have the formation of the earth, and then you have different types of rocks, right? This is important for you to know. On the PDF that you got, they also have a rock cycle, right? Different types of rocks and how they form. But here it's just a summary. It tells you that there are igneous rocks, sedimentary rocks, and metamorphic rocks. In terms of what are igneous rocks, you go back to your PDF document, they explain it thoroughly of what are igneous rocks and whatnot. But based on the explanation, I will just touch on the things that are important, but it does not mean that everything else because you need to understand where does it come from, right? So we have different types of rocks. Igneous rocks are the primary, we call them primary rocks because they form due to from magma, right? So you'll have all that explanation about volcanoes that will tell you on the document that you read. They tell you that there's a volcano. When that volcano solidifies, right? They talk about intrusive and also they talk about extrusive, right? So intrusive rocks are the rocks that form, intrusive rocks are the rocks that will form when the magma solidifies, right? So they will form, but they solidify still not on the surface. So we call them intrusive because they're still inside and they're not on the outside. So everything that's extrusive, it's the cooling of the magma, but on the surface of the earth. So we actually see this process with the naked eye when we talk about the extrusive. Sedimentary rocks and metamorphic rocks, you will see when you are looking at the rock cycle, they form from igneous rocks, right? So that's why they say igneous rocks are primary rocks, and then everything else. Sedimentary rocks will form due to transportation, erosion, and then we'll have that. So based on those three types of rocks, the primary ones are the igneous rocks, and they form from that. Now, why do we need to learn this? We will now focus, this is just an explanation. So towards the end, I will explain what is it that you need to focus on when you're studying and what is it that you learn for understanding, right? So they just tell you that Earth is a differentiated planet where its constituents material are separated and segregated into layers, right? So the most important thing that you need to understand, they say it's segregated or separated into layers according to its density, right? And they tell you that the dense material is concentrated near its center, and then less dense material is concentrated near the surface, right? So the internal layers are named on the basis of chemical composition and then physical properties. This is the example. So when we are talking about the layer of the different layers of Earth, sometimes you will be asked layers of the Earth based on chemical properties, right? When you look at this diagram, that's when they talk about the core, the mantle, and the crust, right? And then when they say based on physical properties, then you need to know that you have an inner core, outer core, mesosphere, asthenosphere, and the lithosphere, right? But in most cases, when we deal with this, we'll just focus on the layers of the Earth based on chemical properties. That's where we have the core, the mantle, and the crust. Please take note that everything that we build is on the crust. When you look at that diagram, and then there is that this small section here where they tell you that the crust is 8 to 75 kilometers in depth, right? So there's nothing that's way deeper than that, because if you look at a kilometer itself, it's something that is very long. So the crust on its own, it's about 75 kilometers in depth so when you're standing on top of the earth, you are gonna go down to a depth of 75 kilometers. That's the only time then you will start being on the second layer of the earth. So everything, to be honest, it's based on the crust. So that's why normally we focus on the crust, because that's where our building activity happens. So they say that the crust is solid, the average thickness is about 30, and then they tell you everything about it. And then they tell you that the two types of crusts, oceanic crust, which consists of basaltic rock, and continental crusts made up of granite, for information purposes. And then they show you that's the crust, and then everything that has to do with tectonic plates moving and everything. How do you then see the different layers? Then that's the example. And then the mantle, they tell you that it's immediately below the crust and it extends to a depth of 2,900. We don't really deal with this in depth because that's not where we are. Our focus is mostly on the crust, but you will be told for information purposes that you have a core, you have a mantle, and then you have a crust. These are the properties of the core, these are the properties of a mantle, and then these are the properties of a crust, right? And then from there, the most important thing, which we're gonna actually discover and explain thoroughly, is the minerals. Why are minerals important, right? So what happens is when these volcanoes activities are happening, right? We're saying that the rocks, especially igneous rocks, they form from those volcanoes or magma, right? So it solidifies. So what happens is that this magma or the volcanoes, they have minerals, right? So these rocks that will form, they will form based on the minerals, right? So the minerals will determine how strong or how weak a certain type of rock is, right? So that's where you will now deal with different types of minerals and then also the bonding, right? So the minerals are important in that sense that then you need to understand what's a mineral. And then they say mineral is, so for you, right, for you to say this is a mineral, it has to have these 5 things. It has to be naturally occurring, it has to be inorganic, it has to be solid, it has to have a limited range of chemical composition, and then it also has to have an ordered atomic structure. That's a mineral. So let me just make an example. If I say to you, is maybe let's say is water a mineral, right? So you need to look at these things. You say, okay, water. So if I say, is water in its liquid form a mineral? So you need to come here and say, is water naturally occurring? Is it inorganic? Is it solid? Does it have a limited range of chemical composition? Does it have an ordered atomic structure? And then you say yes or no, based on this understanding of, does it have all these 5 properties? If yes, then you say yes, water is a mineral. If you're going to say no, then you say no based on why. So if I ask you a question or there's a question that comes, right, and says, is this substance a mineral or not? Then you don't just say no. You say no and justify your answer. So that's number one. That's one thing that you need to take from the beginning, because the material subject, the civil engineering material subject on its own, it's basically on mostly based on theory. So when you answer a question, so when you learn, it's not like you learn that you're gonna cram. No, you learn to understand, and you're going to apply that knowledge on something else, right? So I'll make an example now, and then I ask you, is salt a mineral? So the question is salt a mineral? Whether you say yes or no, it has to be based on these 5 things. You need to look, is it natural occurring? Is it inorganic? Is it solid? Is it, you see, so all those things you need to look at. So whether or not salt is a mineral, then you'll make an informed decision on whether your answer is going to be a yes or a no. So it must not be that at any point when you're asked a question, you're gonna maybe want a question to be define what's a mineral, and then the question stops there. You can be asked, define a mineral, or what is a mineral? And then you need to say, no, a mineral is a substance that has maybe these 5 properties, or characteristics rather. And then if you have a follow-up question based on that, you can't say no, but I don't know this. No, you already know the basic of what is a mineral, and whether how you apply that knowledge on answering a question will be based on your own understanding. So please take note of that. Now, they also tell us that
I'm sorry, ma'am.
Yes, sir.
I'm sorry to interrupt you, ma'am. I just wanted to understand here. In order for it to be a mineral, would it have to fulfill all 5 of those points, or is it just a
Yes,
couple of them?
all 5 of them. Let's just go back to that thing, right? So I said to you, is water a mineral? Okay, and I said in its liquid form. When you look at here, they say it has to be solid. It has all these 5 characteristics, 4 of them in its liquid form, but it's not solid, right? So we've already established that, okay, water is not a mineral in its liquid form. But if I ask you, is there any instance where water can be a mineral? Then you need to think. Someone must say yes, and someone might say no. If I ask you now, if I place water and then in the fridge, maybe, and freeze the water, and then it becomes cubes, like water cubes, is that a mineral? Are those cubes a mineral? No, it's still a no, because the process of hardening or maybe freezing, it was man-made. It's not natural. But snowflakes on its own, snowflakes are in that form. Water is a mineral because snowflakes are not created by anyone. They're not, they are inorganic, they are solids, they have a limited range of chemical composite, and they have an ordered atomic structure. So in a liquid form, water is not a mineral. If I take water, place it in a freezer, and it freezes, it's still not a mineral, but in its own naturally occurring process whereby you have the snow, in terms of snow, yes, it is a mineral. So it has to fulfill all 5 of them. Even if it fulfills 4 of them, but does not fulfill 1, then it is not. And you basically say this this is not a mineral because it fulfills 4, but it lacks this one. Therefore, it is not a mineral. So for something to be a mineral, it has to have all 5 of them. And then when you get a question, you need to critically think about in what form, right? Because remember, water can be gas, liquid, or a solid. So when you get, it's not like every time a question will say water, but water is just one that is just out there. The other thing I asked about is maybe salt, right? You need to understand, what is salt? How is it formed? How does it form even? If you don't know, then it might mean that you cannot apply, because if, let's say, you don't know how a certain object forms, then you are not able to actually comment on it or make an observation, an accurate one, because you don't know or you are not sure. Therefore, your answer will not be accurate because of that. Now they say the same minerals, right? We say, okay, it's important for us to understand minerals because our rocks, they will form from those minerals. And then the type of mineral and whether the rock was formed intrusively or extrusively, says something about the hardness. And then from there, we are going to go to the density, right? You're going to start from hardness. Where does it come from? It comes from the type of mineral. And based on, was the rock formed intrusively or extrusively? And the other thing is, the other thing that will come into play is the environmental conditions as well, right? Because they have they can change these things. So now they say minerals, they have their own physical characteristics, right? All 8 of them. So there is a crystal from through a process called crystallization. So these minerals, they harden and then they crystallize, right? They also look at the color, right? So the minerals, different minerals, when they harden or when a certain rock is formed from a mineral, maybe some of them are dark or maybe some of them they're lighter in color. What does that mean, right? And then there's also something that we call a streak. They say a streak of a mineral is the color of its powder, right? So when you're reading through the document, they tell you that these are the physical characteristics that you can use to identify a mineral with, right? I said what? Physical characteristics. So I just spoke about color, but when I speak about streak again, I refer to the color. So let's make an example. If you look at, if you get a rock that is, maybe it was formed and then it's exposed to extreme hot conditions or maybe even water, right? When you look at that mineral, you're gonna see this color, but it might not necessarily mean that this is its true color. You need to take into consideration, was it exposed to any environmental conditions that might have changed it? If the answer is yes, then it means that color might not be an accurate way to identify a mineral with, because it might be that this type of rock was exposed to harsh conditions in terms environmentally. So if maybe a question comes and then they ask you between streak and color, which characteristic will be better to identify a mineral with, then the answer will be the streak, because they say that the streak of a mineral is the color of its powder. That will never change. Never mind, or it does not matter how much it was exposed to certain conditions, but at the end of the day, the color of its powder will always be the color of its powder. But in terms of how you look at it with the naked eye, might be deceiving based on whether that type of rock was exposed to any environmental condition, harsh conditions. So, and then the other thing they say is the lustre. It's the appearance of a fresh surface of a mineral when it reflects light. So what they do is they will take light and then take a mineral or a rock and then expose light through that mineral, and then how the light is reflected, then that's when they know that, okay, so maybe let's say we're dealing with granite or you're dealing with feldspar. Those are different types of rocks, right? So they already know that for this type of rock, this is what we are expecting. For this type of rock, this is what we're expecting. If there's anything that is out of them, so even if maybe let's say you pick a rock and you look at it, and according to your analysis you look at it and you're like, okay, this is maybe granite, but when you go and expose it to the light, it gives you something else. It means that maybe through the naked eye this is what you're seeing, but it's not accurate, because the most accurate way to deal with a rock or a mineral will be based on the most accurate characteristics. In this case, we said things that will never deceive you. Color can deceive you. The color of a mineral or the rock can deceive you, but the streak of that color will never, right? So the other thing is, maybe the other thing you might not be sure when you're looking at it, but the lustre of it will not deceive you, because these are more like tests that are done to identify that mineral. The other thing is the density, right? Remember we said these minerals, the rocks will form based on minerals, and there will be different types, right? So let's say when we're dealing with the density part, the rocks that will form intrusively by default, because what happens is intrusively there is heat, right? So it's relatively more warm than on the surface, because on the surface we have wind that's blowing and everything that's associated with the environment on the surface. But intrusively, the crystallization process, it's slow. There are no harsh conditions that may hinder the process of crystallization or maybe even accelerate the process. Let's make an example. A rock that you find on the surface, the density will be lower. The rock that you will find that was formed intrusively, an example is a diamond. It's hard. And even the crystallization process, it's stronger. Therefore, that type of rock is strong in terms of density, its hardness, and everything related to it, as compared to a rock that formed on the surface. So what happens is this magma, when it comes on the surface, the crystallization process will be rapid. And therefore, because the crystallization process is rapid, the rock will not be as strong, right? So that's the difference that you'll find. That's why, because diamonds are rare, we don't build houses with them because they are not abundant. And they are rare types of rocks that you don't find just anyway. So when it comes to density, then the density will also differ. There is a rock that is on the surface, but these two rocks that are on the surface, they were formed on the surface, or the magma solidified on the surface. But this one has a higher density than the other one. How can that be? What comes into play is, remember we said the igneous rocks will form. After they form, then we will have a process of maybe erosion, even transportation, because that's how the other rocks will form. Then you have sedimentary rocks. It might mean that these rocks, even though they are on the surface, in terms of the environmental conditions or even exposure, some rocks will be exposed to rain and some will not, and everything. They have a part to play on then the density of these rocks, right? Something that you also need to maybe take note of when we say minerals are important to understand, right? When you look at a rock and then you say, okay, we have a rock. This rock was formed and then there are minerals in it, right? So some minerals, when exposed to water, what will happen is they will those minerals, when reacting with water, because remember we have hydrogen molecules and oxygen. So some of them, when they come into contact with those minerals or with water as it is, they will melt. An example of that is salt. Salt forms naturally, but when in contact with water, what does it do? It melts, right? So you need to look at that and also understand that just because rocks are on the surface, not all of them will be the same. They will not be the same and they will not react the same based on the mineral that formed it and therefore its density, right? So what I'm coming to is, just because a rock is on the surface, it does not mean that all of them have the same density. The density might be different based on different factors. So those are just some of the factors that I told you. The type of mineral that formed the rock comes into play, and also depends on when now exposed to environmental conditions that are harsh, sometimes might not be even harsh, how does it react? That type of mineral, how does it react? Then it tells you whether this type of rock, can we use it to build or we cannot use it to build, and why can we use it and why can we not use it to build. The other thing they look at is cleavage and fracture, right? So what this means is, when now you go and maybe take a rock, right? So they fracture, right? So sometimes they cleave, sometimes they fracture. There is a difference between cleavage and fracture. So when they say cleavage, it means that this rock will still break, right? Let's say you have a rock that's on the surface, it's exposed to different conditions, and then you see that it's breaking. So when it's breaking, it's either it will cleave or it will fracture. When it's cleaving, it's when the breaking is kind of arranged, right, in terms of lines. But then when it fractures, it's just that it just breaks and then there is no pattern in the way it broke. That's fracture. And the cleaving part is when the breaking of the rock is more like it's arranged. Then that's when we say this rock cleaved and did not fracture. So also different types of minerals, they will either break or fracture depending on what type of mineral formed that rock, right? And then we also look at the hardness. So the hardness, they say the resistance to being scratched. So this one we also addressed when I was saying, when you take a rock that is on the surface extrusively, formed extrusively, and a rock that formed intrusively, it will be different in terms of hardness. So what they do is they will take a rock and then try to scratch another mineral and try to scratch this mineral that you're trying to find. So if that type of mineral, so let's say, this is an example. If you take granite, right? Or you take salt particles, let's say granite because it's better. Or maybe a sandstone. You take a sandstone and you take a diamond. You take this sandstone that you have and you try to scratch a diamond. What will happen is nothing will happen to the diamond, because in terms of the scale, it's from 1 to 10. Please just look at the PDF that you have. From 1 to 10, the diamond will be on number 10. That's how strong it is. And maybe the sandstone that you have is somewhere there on 2 or 1. So it means that that type of rock cannot scratch the other one. So that's how they test the hardness. But also we said the hardness will be different depending on how did it form. Was it intrusively or extrusively? Now, the other thing, the other physical characteristic that they also deal with is the ability to withstand being deformed, right? If you take different types of rocks, right, especially the ones that will form, some rocks, when you try to break it, they will break. Some will not. The ones that were formed were intrusively because they are way stronger on the hardness scale. They may be at number 10, like your diamond. When you try to break them, it's very difficult to break them because they are stronger. Their crystallization, their crystal form is way more tight and closely packed. Therefore, you can't just break it. So they look at these things. So when you are out there and maybe you see a rock, or this, in this case we refer to it as a mineral, because these rocks are formed from minerals. So they would, in terms of the physical characteristics, things that you can look at to identify these minerals, these are the 8 things that they look at. And remember, we said in this list of 8 things, the other things you cannot really focus on and say, we are definitely dealing with this is this mineral we are talking about, because or maybe the soil is dark, or sometimes soil can be contaminated, right? So if soil is contaminated, it means that it will change its color. In this case, when you look at topsoil, soil that is mostly contaminated, it tends to be dark in color. But soil that is just okay, it may be mostly brown, depending. Some soils will be red, some brown. There are soils that are even dark or maybe black in color. But mostly, you are not sure if you don't know whether the soil is contaminated or not. So just realize that when I'm talking about this, sometimes I refer to soil because soil is it's a practical example that you are able to understand, because these rocks, they form from minerals. So don't say, I was confused. Was she referring to minerals or was she referring to soil? No, we're referring to minerals, but the same soil that you see or the rocks that you see, no matter how small the particle is, it is formed from minerals, and they get their color from those minerals. So that's why it's important for you to understand the minerals and different types of those minerals. Now, the other thing that we are kind of going to go back to is the different types of rocks, right? So we said these are the types of rocks that we have: igneous rocks, sedimentary rocks, metamorphic rocks. Igneous rocks, we said they form from magma or the volcano when it solidifies. It can either be intrusively or extrusively. Now, what are sedimentary rocks? Sedimentary rocks, they form from igneous rocks, right? How do they form from igneous rocks? So sedimentary rocks, just think about sediments, right? So when we talk about sedimentary rocks, they will form from igneous rocks. How? The same igneous rocks, they will be transported or moved either by air, by water, through the process of erosion, right? So a rock can form and then it has a particular shape. Its shape can change depending on how long was it exposed to transportation. Even if you take a rock particle, let's say it's a solid particle, and then maybe it has an irregular shape. That same rock, when exposed maybe to water, it was exposed to water and it was traveling either through slopes and whatnot over a long period, you can find the same rock now being round. That's why when you get to the beach and you look, there are small particles. Some of them have irregular shapes, but some of them are kind of roundish. What happens is these rocks will form, and then through the process of transportation, because they're sediments, right? So when we say they're sediments, we look at them at each and every particle as an individual. They can be changed, or they change through time. And then what happens is, we are going to make an example. You are on a hill, right? Or on a slopey surface. If it's raining, right? Even just try to practicalize this or look at it practically. If you are on a mountain, or you are on a hill, or you are on a slopey surface, and the slope is not strong enough, when it rains, what's going to happen? The water, as it goes down, is going to come with particles of soil, and then they settle at the bottom. Again, when it rains, some particles will come, and then there's another layer on top of the first layer. Through time, what's going to happen? The first layer that you had at the bottom will be way at the bottom, and then at the top we have something else. So what happens is, because of the change, that's when the metamorphic rocks will form. So through heat and pressure. Where's the pressure coming from? Number one, the heat. It will come because there's that particular type of layer. It's no longer at the surface, but it's at the bottom because some other layers are coming on top of it. there is heat. The other thing will be pressure, because the other layers that are coming, they are pressurizing the layer that was initially at the top, but now it's at the bottom. So what happens is that particular soil or the type of rock that will form, because what will happen is it will solidify. It will no longer be fragments, but it will be like a layer of soil that is now solidified. Because it's solidified, it will change and be solid. Now it's solid. We freely refer to it as layer of rock, right? This layer of rock, it will be exposed to heat and pressure. And then it has the ability to change. So that's how the metamorphic rocks will form from sedimentary rocks. We said our primary rocks are igneous rocks. From igneous rocks, we get sedimentary rocks. And then from sedimentary rocks, we also get metamorphic rocks. So look at that and remember that. Also go and look at your rock cycle, because they explain it thoroughly. So whatever it is that I'm saying, you'll see that they will kind of explain it and you're able to understand it fully. How a rock can start from being an igneous rock, but maybe later we now refer to it as a metamorphic rock. So that's what happens. So these igneous rocks, there will be types of rocks because they will be different. Remember, we said just because a rock is an igneous rock, it does not mean that all of them will be the same. Not all of them will be the same. And why are they not the same? They will not be the same because they are formed from different minerals, and even the solidification process or the crystallization is different. Therefore, we'll have different types of rocks. They will have different colors as well. So igneous rocks, these are the typical rocks that you can find that fall under igneous rocks. Sedimentary rocks, it's the same. They're secondary rocks, and I explained why they are secondary rocks, because they are formed from igneous rocks. So your sandstone, your shale, your gypsum, your dolomite, all those types of rocks, they fall under sedimentary rocks. And then finally, you'll have your metamorphic rocks. So these ones form because of extreme heat and pressure. And how does that happen? I just explained with that scenario of a slopey area, and then at the end, you might end up getting a metamorphic rock. It does not mean that that's the only way they'll form. It's just that that's the most simple example that I'm giving you so that you're able to understand how can a metamorphic rock form from a sedimentary rock. And then lastly, the other thing that we need to look at, remember we said we are not just going to look at these rocks or these minerals. Why are they important to us? Because we use them in the construction process. Civil engineering materials, these are the materials we use when performing or building these structures that we have. So at the end, we're not going to just look at rocks, we're going to look at them, understand their properties, understand their minerals, so that we know that this type of rock, we can use it to build this, we can use this rock to build this, we can use this to build that. So this is a list of uses of rocks in civil engineering. So a block of stones are used in foundations, walls, bridge, pier, abutments, lighthouses, and retaining walls. They're also used for masonry work, lintels, vertical columns covering floors of the buildings. Flag or thin slabs are used for paving or roofing. Broken or crushed rocks are used as aggregate in concrete in road construction. Broken or crushed rocks are also used as railway ballast. Stone screenings are used as a natural substitute for sand. Limestone, they use it as a basic material for manufacturing of lime, concrete, or cement. Rocks are used as blocks along the river and canal banks for preventing erosion called riprap, base material for water, sewage filters in case of waterworks and sewage treatment plants. Limestones are also used as a flux in the blast furnace, in the construction of the masonry dam. Stones of good quality and durability are of vital importance, so that's where they use them. And then sometimes for ornamental works in and outside the buildings, like blocks, slabs, and chips. So in summary, you need to understand, if you can just give yourself time and walk around, everything that you see, you will basically understand that it forms from, in terms of buildings, it comes from rocks, right? We actually not talking about here we're not talking about wood or anything, but everything that has or related to rocks. You will see that minerals, it's important to understand them, because then we know this type of rock, we can use it for this because of its durability, strength, or maybe hardness. Then we can use it for this, we can use it for that, or we can use it for that. Even in terms of different types of bricks, there are different types of bricks that are formed from rocks or even soil, if you want to call it like that. But different types of bricks will be used for different types of conditions, right? So it's very important for you to understand that when we are dealing with this chapter of geology, what are you taking from it? You're taking the fact that you understand that this is how minerals form, or this is how rocks or the soil will form based on different types of minerals. These minerals, they have different characteristics, different properties, and mostly they have different, in terms of color also, they will be different. They form different types of rocks. These different types of rock, even though they're igneous rocks, they don't have the same strength or density. Therefore, it's not like we have a blanket approach whereby we say just because something is an igneous rock, by default we can use it for this because it possesses that amount of strength. No, that's not how it works. How it works, it will be dependent on the mineral and where the rock was formed. Was it intrusively or extrusively? And it also gives you an idea of, we cannot go and build with diamonds because they are rare and they are more expensive to get. So for you to get a diamond, you need to mine it. And that process of mining something, it requires resources. Economically, in terms of economics, it does not make sense that you would build with a with a diamond, but it definitely makes sense that maybe you will build with rocks that are abundant on the surface. Maybe an example being a sandstone or any type of rock that is abundant and you can use. So it's very important that you please remember that the idea is for you to understand, where do rocks come from, or the soil, where does it come from, and how do we make an informed decision that yes, this one we can build with, this one we cannot build with, and the reasons for not building or building with a certain type of material. I'm going to stop here. So that was just a summary of what the introduction to geology, or what the geology chapter itself, why is it important, and why do we need to start with that chapter before we go on the second chapter, which is soils. So the next chapter that we are going to deal or cover is soils, right? So you have geology. From geology, we move and we go to soils, right? So it's important. So when we are explaining or going into details on the properties of soils, different characteristics, or different types of soils, and why will that type of soil react in this way when mixed with water, but the other one does not react in that way? What causes that? It will be based on the minerals that are present on that particular type of soil. So that's why this chapter was important, and that's how it feeds into the other chapters as well. Thank you. Do you have any questions? Questions? No questions. Okay. Let me stop the recording.